Okay, this is a video that goes along with the set operations notes. Make sure you have those printed off or you're taking your own notes. But yeah, this has quite a bit of vocabulary, some that we've already had, but others that be brand new. It starts off with equal sets. What are equal sets? Now, to be sets that are equal, two sets that contain exactly the same elements are called equal sets. And that's exactly the same, not just the same number. So if set A has 1, 2, 3, 4, 5, set B has 1, 2, 3, 4, 5, those two sets are equal, and we can write A equals B, which would mean set A equals set B. Set C has red, white, and blue. Set D has blue, red, and white. Well, since those don't have a necessary order, then they do have the same. Is blue in both sets? Yes. Is red in both sets? Is white in both sets? They both have three elements. They both have the exact same three elements. So yes, C is equal to D. And of course we could write the opposite if you ever need to. B is equal to A is the same thing. D is equal to C, that's fine. So look first, pause if you need to pause, but see if you can determine which two sets are equal in that list of sets. Equal meaning they have the same number of elements and those elements are the exact same. Alright, so I'm going to start with P and I'm going to compare it to each one. If it doesn't equal any of those, then I go to Q and check it with the next two, and then R, so forth. So P has A, D, K, T, Z. So does this one have the A? Yes. Does it have the D? Yes. The K? No. So these two are not equal. We'll move on to the next one. Does this set have the A? Yes. D? Yes. K? Yes. T? Yes. Z? Yes. So this set is the exact same as this set. And if P and R are equal, and P does not equal Q, then R can't equal Q. What about the last two? Are they equal? Well, D, nope, this one has B. So they don't both have D. So you can say that P equals R, or you could say R equals P. Either way, same thing. Okay, so equal sets, exactly the same. And I don't know if I've mentioned to this point, but sets don't repeat. If you have an element that 1 in a set, you won't have the number 1 twice in a set. It doesn't work that way. Each element should be a unique item. Unique meaning nothing else is like it. So there's a 1, there's only one 1. If there's the color blue in a set, you won't have blue twice in the same set. Alright. So, two sets that contain... Oh, next is equivalent. And that's different than equal. So where equal is exactly the same, equivalent just means that the two sets contain the same number of elements. They have the same cardinality. They don't even have to have the same stuff in common. One can have numbers, one could have letters. One could be names, the other one be colors. But if they both have 4 elements, then they are called equivalent sets. Right? And equivalent sets would have the same number of subsets and the same lots of common things in them. They're just not exactly equal. So all of sets in 1, all of these sets up here in question 1 are equivalent sets. Even the two that are equal are also called equivalent because they have 5 elements. 5 elements, 5 elements, 5 elements. They're all equivalent. Alright? Alright. I think that's pretty self-explanatory. And we'll have some questions, or you'll have some questions on the assignment on equivalent sets. So just have to have the same number of elements. Alright, intersection. The intersection of two sets are all of the elements that the two sets have in common and it's denoted with this symbol. That's an intersection symbol, upside down, tunnel looking thing. But that means exactly what two elements, they both have to have those elements to be in the intersection. So like for the example here, set A, 10, 15, 17, 20, 24, 32, 41. B has 13, 16, 17. Well, 17 is in both of them, so 17 would be in the intersection of those two sets. 22, 24, 33, 41. So their intersection would be 17, 24, 21. A intersect B would equal those three that they have in common. So again, if you want to pause for a second or try to see if you can find the intersection of X, what is X intersect Y is how that'd be read. So X intersect Y, it's a subset. Even if there's nothing in common, it would still be a set, an empty set. But the intersection of two sets is always a set. So you need the braces. Alright, try that one. Okay, so I'm just going for things that are in common. Do they both have red? Yes. So red, and if yours is not in the same order, it doesn't matter because these colors don't have a necessary order. Do they both have green? No. Set Y doesn't have green, so that's not in the intersection. Pink? Nope. Yellow? Yellow. Yellow and yellow. So yellow is part of the intersection. Black? Black? No. Purple? Purple? No. So the only two colors, I didn't need that second comma, only red and yellow are part of the intersection of X and Y. All right. Intersection. There's the dog barking again. I don't even know if you can hear that, but all right. Next one, union. The union of two sets are all of the elements contained in both sets combined, and we write union with that U. Be careful, that U is different than the U we use for the universal set, which is a capital letter U. But union is taking the two sets, put them together, but don't write anything twice if it's in both of them. So here, if set A is 3, 5, 6, 8, 9, set B is 2, 4, 6, 9, well, if I'm going to go in order, since these do have order, then I'm going to say 2 is part of my union, right? Because I'm just putting the two sets together. 3, does one of them have a 4? Yes, so 4. One of them has a 5? Yes. 6, well, they both have 6, but don't write it twice. And it is in their union with both of them. 7, nope. 8, yep, there's an 8. And then 9 is in both of them, so 9 would be in the union. So when you write the union, then both of these sets have to be a subset of their union. All of these numbers have to be contained in the union. All of these numbers have to be contained in the union. Where if it's an intersection, the intersection has to be a subset of both of the individuals. All of these numbers have to be contained in set A, and they also have to be in set B. All right. I could even write that out. So A intersect B is a subset of A, and A intersect B has to be a subset of B. That has to be true for both of them. But when you do the union, it's the other way around. A is a subset of A union B, and B is a subset of A union B. That way. All right, so question 3, just asking you to find the union of those two sets. So go ahead and pause or whatever, try that. You could do it alphabetically, it doesn't have to be. Just make sure you include all of them. Some people might just write everything that's in M first and then add on everything that's in N that you haven't already written. Let's look at it that way. So M union N is M. I could do B, E, G, J, P, and then N. There's a C that I haven't written yet. I already have the E, so I'm not going to write it twice. I don't have the H. I have the J already, but I need the S. So that would be the union, the two sets together. All right. Good. Difference. The difference of two sets, which is written A minus B, is all the elements contained in set A that are not contained in set B. When I do set A minus set B, the only possible elements would be the ones left in or from A. I can't add any ones that are in B if I'm subtracting those out. So if you look in your example, A minus B, if you look at A, B has a blue, so that would subtract out. So blue is not going to be a part of it. Yellow, there's no yellow to subtract out, so yellow. White, there's no white to subtract out. But green, there is a green, so it would leave. So A minus B is just the yellow and the white, because they didn't get taken out from B. But if you switch them around, B minus A, now it's all of the elements in B that are not contained over here. So is red in A? No, so you'd write red. Is blue in A? It is, so take it out. Is purple? Nope, write it. Is green? Yes, take it out. Is black? Nope, so you would write. So that, you can't just write either way. They're two different sets. But, and like we're talking about subsets, A minus B has to always be a subset of A, and B minus A would have to be a subset of B. Yeah. So try it. You have 2, 4, 5, 7, and 9, 0, 1, 4, 7, and 8. Do P minus Q, and then do Q minus P. Pause it, see if you can get those answers. Come back, check how you did. Alright, so P minus Q are all of the elements in P that aren't over here in Q. So is 2 in Q? Nope. So 4 gets taken out because it's in Q. 5, not in Q, so 5 gets to stay. 7 is in Q, so it gets taken out. 9, not, so it gets to stay. So P minus Q is 259, and 259 is a subset of P, not a subset of Q necessarily, right? It actually can't be because it would have been taken out. Q minus P means you're starting with Q, and if it's in P, take it out. Is 0 in P? Nope. Is 1 in P? Nope. 4, yes, so take it out. 7, yes, take it out. 8, nope. 8. And 0, 1, 8 is a subset of Q. Alright. How'd you do? Anybody get that right? Raise your hand if you got it right. Good job. Pat yourself on the back. Nice work. Dog, stop fighting. Thanks. Sorry about that. Okay, so operations in the null set. These are just some basic like properties you should know about the null set, the empty set. Intersection, remember intersection is only what they have in common. So if you intersect any set with an empty set, you're just going to get an empty set. Right? If you have a bunch of things, nothing to intersect them with, then union is putting them together. So if you take a set and put it together with an empty set, that empty set doesn't add anything to it, so you just get set A back. The difference of two sets, if you take A and subtract out everything that's contained in the null set, then you're not subtracting anything out. So A minus the null set would leave you A. If you have the null set and you subtract out, remember when you do this subtraction, your subset has to be, or your answer has to be a subset of the empty set. Well, there's no other subset of the empty set than the empty set. So if you take the empty set and subtract out everything that's an A, well, you didn't have anything to subtract out to begin with. So that's the empty set. All right, so those are just operations with the null set, properties that you need to remember. All right, and then the last video, we already talked about the complement. Now the complement of a set is all of the elements, given that a set is a subset of the universal set, the complement of the set is the subset of the universal set that contains all of the elements not in the original set. The complement can be noted as A to the C power, or A with a little thing, we call that A prime, that little mark. I'm going to be using A prime, but remember A to the C power is the same thing. So when you talk about complements, you need to know the original universal set, the set that everything is being built off of. So in this case, for our example, we're going to take the three primary colors, blue, red, and yellow. That's our universal set. So if set A is just blue, then A prime, or the complement of A, would be the other two colors, red and yellow. And if you remember, red and yellow make orange. And for all of you art people out there, you learned with the color wheel, what is the complementary color to blue? Well, it's orange. It's the color across the color wheel. Well, the reason it's called that is because the two colors that make orange are the complements of blue in that set. So yeah, complementary color. Just like red, what's the complementary color to red? Well, blue and yellow make green, right? Oop, can't even spell green, but it's green. So there's where, because the complement to red in this set of primary colors is blue and yellow. And the complement of yellow is blue and red, or purple, as it were. But these, I'm just showing you for the art people, these are not even choices for our sets, because they're not, we can't mix two parts of a set together in set theory. But, okay. So now, with that being said, last one, take a minute, try question 5. It's got a bunch of different questions about it. But my universal set is you, Tina, Bob, Louise, Linda, Jean, Teddy, Mort, and Jimmy. And then a bunch of different subsets. A has 3 people, Tina, Linda, and Mort. B has a couple, Bob and Linda. C has Tina, Louise, Jean, and Teddy, Bob, Mort, and Jimmy, Tina, Bob, Louise, Linda, and Jean. And then based on that, try all of those. All right. Hopefully you paused and tried these. What is A complement or what is A prime? Well, that is the set. So as we look at the universal set, it's all the ones that aren't in A is A prime. So Tina's in A, not going to write it. Bob's not, so I need Bob. Louise is not, so I need Louise. Linda is there. Jean is not. Teddy is not. Am I blocking? Mort is in the set, and Jimmy is not. So 1, 2, 3, 4, 5, 6, 7, 8. The cardinality is 8 for the universal set. So if A has 3, then A prime has to have the other 5 to make 8. And when you put those together, if I were to do the intersection of those two, would always be empty, right? Nothing in it because they can't intersect. They're complements of each other. But the union of those two, if I put them together, would give me back the universal set. Is that a question on your... Yep. You'll see that question on your assignment. Okay, so C prime. There are 1, 2, 3, 4. So my in C, so C prime has to contain the other 4 people. So Tina's there. Bob is not. Louise is in that set. Linda is not. Jean is in that set. Teddy is in that set. So it still needs Mort and Jimmy to make the 4. And then E prime, or the complement of E, 1, 2, 3, 4, 5, has to be 3. It's the 3 that are missing from set E. Tina's not missing, Bob's not missing, Louise, Linda, Jean. It's Teddy, Mort, and Jimmy. All right. So then when you start doing some of the unions, intersections of that, with the prime, I would write them out. So A is Tina, Linda, Mort, and I'm going to intersect that with, you guys see all that? I'm going to intersect that with C prime. Well, we already wrote C prime, but again, we could get it from, it's got to be 4, right? If I didn't have C prime here, I could say, okay, Tina's not in C prime, Bob is, Louise is not, Linda, Jean is not in it, Teddy's not, but Mort and Jimmy. My horrible handwriting, sorry about that. But even if I have room, intersection is what they both have. Do they both have Tina? Nope. They both have Linda? Yes, she is in the intersection. And do they both have Mort? Yes. So Mort. And the intersection, if this one has 3 and this one has 4, the intersection can't be more than 3, right? Because this has to be a subset of both of them. All right. Using that C prime again, we'll just write that down. We won't go through it again. Bob, Linda, Mort, and Jimmy. This time I'm going to union with D prime. So D has 3. So again, that there are 5 in D prime. Tina is not in D. Bob is. Louise is not. Linda is not. Jean is not. Teddy is not. Mort and Jimmy are, so that should be our 1, 2, 3, 4, 5 that are in D prime. And now the union is putting both of those together. So again, when you do the union, you can just Bob, take the first set. They have to be in the union. Linda, Mort, and Jimmy. And then add on anybody that's not already in the set. So Tina needs to be added on. Louise. Linda's already in there. Jean. And Teddy. One, two, three, four, five, six, seven, 8. All 8 of them are in there. So I could write them all out, but if I realize it's all of them, I could have also said that it's the universal set. That when you do those two together, you get everybody, and it doesn't have to be in the same order, but you get the universal set. All right. Finally, let's look at E minus B prime. So E is, I'll do it down here, Tina, Bob, Louise, Linda, Jean, minus, all right, E, B prime. We haven't done B prime. Well, B is Bob and Linda, so B prime is everybody but Bob and Linda. So that's Tina, Louise, Jean, Teddy, Mort, and Jimmy. So E minus B prime is taking everything in E, and if it's in B prime, or the complement of B, it gets taken out. So Tina would be subtracted out. Bob is not in B prime, so he stays. Louise is in B prime. Linda's not, so Linda. Jean is, so he gets, so I didn't need that last comma, but it would be Bob and Linda. Now we have a subset that we already named that's Bob and Linda. So you could write Bob and Linda, or you could even write, since it's equal, you could write set B, which is true, right? Bob and Linda is set B. All right, so you have an assignment to go along with this set operations assignment. Try those for each one. You definitely want to print this out or write this out. Take a little bit of work and have a great day.